Is methodological naturalism the unwavering foundation of science as commonly believed? Let's delve into this intriguing topic. It is widely held that methodological naturalism, the principle that only natural causes can be used to explain natural phenomena, is the ground rule for conducting scientific inquiries. This term was coined by Paul de Vries in 1983. In his essay Naturalism in the Natural Sciences, de Vries clarified his idea by stating that a pencil falling to the floor or a rainstorm can be explained by natural factors such as gravity or air pressure and temperature, respectively. Essentially, he argued that the natural sciences are limited by what he termed as methodological naturalism. But is de Vries's explanation of natural phenomena like a pencil falling or a rainstorm entirely accurate? Let's scrutinize this further in our upcoming scenes. Consider the humble pencil falling to the ground. Is this phenomenon as natural as we assume? Professor J. Budzajewski, in his article titled Journey Out of Nihilism, would argue otherwise. He challenges us with a simple question: why does the pencil fall? Gravity, you might say. But this answer only names the phenomenon, not its explanation. But there are laws of gravity, you might counter. Yet these laws do not explain the phenomenon either. They merely describe it more precisely. Budzajewski states, for just this reason, philosophers of science are shy of the term laws. They prefer law-like regularities. It's a subtle shift, but an important one. This term, law-like regularities, acknowledges the mystery that surrounds these phenomena, a mystery that the term laws might gloss over, but the mystery deepens. Modern science reveals that gravity is finely tuned to 1 part in 10 to the power of 40. Picture an imaginary ruler stretching across the diameter of the entire universe. This level of fine-tuning is akin to allowing just 1 inch of tolerance on that ruler. An inch of deviation and the universe as we know it would not exist. So gravity, this fundamental law of nature, is not as natural as de Vries presupposed. It's a law-like regularity, mysterious and finely tuned, strongly hinting at an origin that defies simple, natural explanations. Rainstorms, the other example provided by de Vries, is it purely a product of natural factors? Let's delve into this. Michael Denton, in his 2014 article titled The Cold Trap: How It Works, argued that our Earth's capability to produce rainstorms is not just due to natural factors, but is the result of an exceptional fine-tuning process on the planetary scale. Consider this. On Venus, it rains sulfuric acid. On Mars, it snows dry ice. But here on Earth, we have water. Moreover, water itself is now found to possess life-giving properties that exist on a knife edge, a delicate balance of quantum forces. This balance is so finely tuned that even a slight nudge could disrupt life as we know it. And then there's the mystery of lightning. Lightning itself, although it is often considered natural, is still something we don't fully understand. A 2013 article titled, "We Don't Actually Know What Triggers Lightning Strikes" highlights our lack of understanding about what actually initiates this electric spectacle. We see it, we study it, but its spark of origin remains elusive. So when we look at rainstorms, we see more than just natural factors at play. We see a system that is so finely tuned, so delicately balanced, that it defies the simplistic natural label that de Vries put on it. As it turns out, rainstorms, lightning, and even water itself are not nearly as natural as de Vries had originally presupposed them to be when he first coined the term methodological naturalism. So, where does this leave methodological naturalism? Now we've dived into the depths of gravity and rainstorms, unraveling the mysteries that defy Paul de Vries's simplistic claim of gravity and rainstorms being natural phenomena. Gravity, a force we've come to accept as a given, is far from being explained in naturalistic terms. Rainstorms, too, are far from simple natural occurrences, with their genesis tied to the complex and finely tuned conditions of our planet. These revelations challenge the concept of methodological naturalism. They show us that what we regard as natural is not easily explained or understood within the confines of naturalism. Our understanding of the universe is still growing, and what we have previously presupposed to be natural phenomena is turning out to be far from natural. So, when we base our scientific methodology on a presumption of naturalism, as gravity and rainstorms give evidence of, we might just be limiting ourselves to a perspective that turns out to be false. This doesn't mean we completely discard natural explanations, but rather, we should realize that natural explanations have often failed as satisfactory explanations in science. Perhaps it's time to reconsider the belief that methodological naturalism is the ground rule for doing science.